I wanted to quickly go through this question with you today, and it's called water bottles. And the problem description is pretty simple. We are initially given set of bottles, and we are required to drink the maximum number of bottles we can do. Okay, so also there is a catch that there is a number of exchange parameter, which is basically if we drink, like if we, let's say we have 3 empty bottles, we can exchange that for a full bottle and we can drink it again and so on. That's the way we are going to maximize the number of bottles we can drink. So let's just take this example. We are initially given 9 bottles. We drink all of them. We add it to the answer. Then we, for each 3, we can exchange it with a full one. So this is a 1, a 1, a 1. We now have 3 bottles, so 9 plus 3 is going to be 12. And then we can exchange the empty 3 new ones with a full one. We can drink it, then we are left with an empty one. So the total number of bottles we drank is 13, okay? And the second example, we are initially given 15. We drink all of them. Then for each 4, we can exchange it with a full one. And we need to remember that we already have 3, which we can't exchange due to the exchange rate being 4. So we just save them for the next step and so on until we are left with a number less than the number of exchange, okay? So I think you got the idea. So the way I'm going to solve this question is going to be using recursion. And for me, at least, the recursion approach is more intuitive. It also has one solution, which is some sort of math equation, but I don't think this is practical in a manner of an interview. So I think the recursion approach is going to be more practical, okay? So I'm going to have a function called drink, which is going to be our recursive function, and it is going to have 2 parameters. The first one is going to be the number of full bottles, and the second one is going to be the number of empty bottles, okay? And let's just call them number of bottles and empty bottles, and it is going to return the bottles we already drank, okay? So the return from the drink function is going to be the answer, so drink, and we have a full bottles, which is reserved in the number of bottles, and the empty bottles, we should start with 0 empty bottles, okay? And for the base case, I think it's pretty straightforward. If not n, we just return 0. So let's say we are left with no full bottles, we return just 0, okay? So this case and this case, we have literally 0 empty bottles, but we have, full bottles, but we are left with some empty bottles, okay? And for the return, we are going to, of course, we should drink the full bottles, and we should recursively go through the left set. Okay, so let's say here we drink 9, and then we should drink the number of full bottles, which now became empty after we drank them. So we add that to the already empty bottles, and we should convert them by the number of exchange to be full bottles, okay? So I think this is where the core of the problem resides, okay? And for the empty bottles, we do the same way. We take the full bottles and we return the Um, Number of exchange, the module of the full bottles after we divide it by the number of exchange, which is basically those three, okay? So I think I should have a working solution by now. I think so. Yeah, it worked and it's also pretty efficient. So I guess this is it for now. I encourage you to see this tutorial. It has some sort of while approach, which is iterative, but as I said, I prefer the recursive approach, okay? And the O1 solution, I think it is somewhere here. Yeah, this is it. So if you want, you might just read it for some inspiration. Thank you for watching.